Hey, it's Till, and in this video we will be programming a simple calculator with Java and IntelliJ IDEA. The requirements for our calculator are as follows. First, support basic arithmetic with addition, subtraction, multiplication and division. Second, write a simple term into the console that consists of two numbers and an operator, like 34 plus 12. Third, only positive numbers are allowed, so the minus sign does not overlap with the subtraction operator. And the last one, calculate the result based on the input of the user. Let's start a new project by going to File, New Project, call it Calculator, and select JDK 17, download if necessary right from the menu. Click Create. On the left side, go to the main source file. We will start coding by defining our arithmetic operations. For this, we will define four methods that each take two numbers and do the operation on them and then return the result. The first method is addition, that takes two numbers a and b, sums them up and immediately returns the result. The numbers are floats to allow fractional numbers. Let's try it out by calling that method from the program starting point with a equals to 12 and b equals to 43 and printing the result to the console. Let's start the program. Addition works as expected. Let's comment the add method again. The other operations for subtraction, multiplication and division follow suit. Let's scroll down to the main method again. The next goal is to read in user input from the console. In every application we have three streams of data called input, output and error. To access those streams we will use the special system object of Java. To read something that was written by the user into the program, we need to use the input stream. As the input stream only supports bytes and we don't want to work with bytes, we will use some helper to conveniently convert those bytes to text. But first, let's start by writing a prompt for the user so it is clear that input is expected. Here we use the out stream to write something to the console. The same would work for the error stream to write error messages to the console. Those would be printed in red. Okay, so let's see how we can read from system in. As already said, we will use a helper here, so we do not have to fiddle with the bytes of the input stream. We will instantiate a new scanner object and put in the system in stream so the scanner can work with it. By typing in a dot right after the scanner, we can see the method it supports. The scanner provides us with the next method that we can call to read the whole user input. The method also converts it to a string, which is the type for text. Only reading the input from the user is sadly not enough. When the next method finishes, it returns the input, but we do not do anything with it. It kind of just fizzles out into nothingness. What we have to do is save it somewhere. How do we do that? Variables to the rescue. A variable is something you can assign something to for later use. More or less like a little space in memory where you can put something into and then know how to come back to it through the variable. Basically, any object you create, for example the scanner just a moment ago, takes up some space in memory and the variable saves the location so you can use the thing in memory again. We did not create a variable for the scanner as it was not needed. Would we have wanted to call next multiple times, it would have been smart to create a variable and save the scanner for reuse. In layman terms, we say that we save something in a variable. Let's use a variable to save the result of the next method, call it term with type string. So we have the user's input now. The next thing we need to do is pass the input into usable data for us. We will start by finding the operation that was input by the user, as it is this thing that determines what arithmetic method we will use and conveniently also sits in between the two numbers, thus we can easily split up the term into its parts. We will define two additional variables, one to hold the symbol of the operation that was selected and two to save the arithmetic method that should be used to calculate the result. The types are string for the operation symbol and by function for the method. The symbol is needed to split the term into its parts, and the method is needed so we know how to do our calculation. We will save the symbol and method in variables so we do not lose the knowledge on what we found in the term. We need to do it like that as we do not know what the user inputs. That's why we ask the term if it contains something. Let's do it for addition. If term contains plus, then the operation symbol is plus and the operation method is addition. So when we find a plus symbol in our term, we will save that the symbol found was a plus and also that the add method is to be used later in the program. The other arithmetic methods work in the same way. Let's write it down. We will start the program again in debugging mode. With debugging mode, we can have a look at the current state of the program at a given point in time. Let's put a debugging breakpoint right after the conditionals. Start the program. Type in 2 plus 2 and enter. And have a look at the debugging window at the bottom. Here we can see that operation symbol was set correctly to plus. Okay, so now we know which arithmetic operation was taken and how it is to be calculated. Next thing to do is pass a term for the two numbers. To do that, we need to find the operator symbol in the term, and that's why we save the operator symbol in a variable. The indexOf method of string finds the first occurrence of a given text. We will use this to find the position of the given operator symbol and save it in a variable. With this index, we can say that to the left of the operator symbol is a number and also to the right of the symbol is a number. We will take this knowledge to split the term exactly at the index of the operator symbol. The substring method can cut out parts of a text. We will use it to get the left and the right side of the term. The left side is from 0 to the position of the symbol, and the right side is from the position of the symbol plus 1 to the end of the string. The result are the left and right numbers as strings, but we need those as fractional numbers. Let's define the variables with type float and use IntelliJ's autocomplete to convert the strings to numbers. Press Alt-Enter on the red squiggly lines to trigger autocomplete. As you can see, we use the float parsFloat method to convert those strings to numbers. The hard work is done. Now we only need to calculate the result by using our saved operation method and print the result to the console so the user sees the result. For that we call apply on the operation method variable and put in the left and right number. Start the program and test it out. I will try 43 plus 55. Let's try again with 4 times 8. Seems like it's working as expected. And that's it. In this video you saw printing to console, reading from the console, variables, conditionals and string operations like contains, indexOf and substring. If you have any questions left or would like to tell or ask me something, then please leave a comment. If you liked the video, then please leave a like. If you want to see more of those videos, then also subscribe to my channel. See you in the next one.